you can learn it quickly. You can write Julia programs quickly, and it will run very efficiently on the hardware. Given that it's a technical computing language, I guess everyone here is thinking, so is this going to make it easy for me to do my next machine learning project? Can it scale to big data? Can it scale to parallel programs? And the answer to all of this is yes. If you look at all the various machine learning frameworks that are available, whether it's TensorFlow by Google or scikit-learn in the Python community, all of these have been plugged into Julia by the Julia community. So you could use these programs as it is. Or the Julia community has come up with new algorithms and new packages, which is called the Julia machine learning packages. And then there are various other deep learning packages, which such as Mocha, KNet, or MXNet. All of these libraries form a very rich ecosystem of open source learning packages that are already plugged into Julia. And you could combine, some of them are sequential, but you could use Julia's parallelism to scale them. Some of them are parallel on their own, so you would use Julia sequentially to access them. It's a very rich ecosystem. It's growing very fast, as I'm sure all of you know. But on the right-hand side, you see all the hardware. So Julia runs on all this hardware and at speed. So whether it's on the cloud in Julia Box running on AWS or Google or Microsoft Azure, or whether it's on GPUs, or the newest Intel chips that are coming out, or the ARM processor on embedded systems, or whether it's the Open Power Initiative by IBM, led by IBM. Julia runs on all of these platforms, and it has a JIT compiler. It's extremely fast. So basically, write your code once and run it almost on all other platforms. Of course, if you use a particular library that's not supported on other platforms, that's going to be trouble. But if you write your code in pure Julia, you are guaranteed to get good performance across a variety of platforms right out of the box. Okay, here's an example. So I'm going to now show a few examples of how people are using Julia, and the other one's not playing. Could you hit play on the GPU one? So you see the simulation on the left. So this is basically taking images of Hurricane Katrina and classifying all the pixels as land, water, basically land, water, and cloud. And could you hit the GPU one again, maybe? So the one on the left is running on the CPU. The one on the right is on the GPU. You can see how fast the GPU computation is. Typically, if you are writing code on GPUs, you would have to go and learn CUDA and write C programs and make it all work. Guess what the difference between these two programs is? It's only the 3 letters. It's actually 1 letter. You replace the C with the G in your Julia code, so that you tell it that run it on the GPU, and it runs exactly the same. So the CPU one is still going. I think we did a few iterations of the GPU one, right? Oh, well, thank you for hitting it once more. And there, it's that fast. Okay, so if you're a Julia, you're like, okay, this is great. There are all these amazing examples. I buy into the vision, into all the machine learning tools, frameworks, all that. How do I develop? Here's the Julia IDE. It's based on Atom, which is what GitHub and Facebook have been supporting. And our goal is to support many more of these IDEs as we go along. But Atom is a very well supported IDE. It's also going to be, so Atom is a standalone IDE, but integrated with Julia, there is a project called Juno. Juno gives you, within the IDE, full evaluation, plotting, debugging, everything in one place for Julia. And Juno is an open source project by itself, and it's also commercially supported by Julia Computing. We are soon going to make distributions of this available for download in the next few weeks as the latest version of Julia comes out. If you are not the kind who likes to install stuff on your laptop or your desktop to try out new things, as often as, that's how I do things. I often like to use, some kind of a cloud service to try things out. We have a service called Julia Box. It's used by thousands of students, dozens of universities worldwide. MIT, Stanford, Cornell, all of them are using Julia Box every year for the last several years now. And you just log in with your Google account or your LinkedIn account or your GitHub account, and you get your Jupyter notebooks right there in the cloud with all the graphics, interactivity, workflow, so on and so forth. If you're more of a desktop user and you have a lot of stuff in Excel, a lot of people love to do data analysis in Excel, right? It's easy to plot charts, it's easy to get data in, massage it, push it out. Julia and Excel are very tightly integrated. This is a product of Julia Computing, where you could simultaneously run Julia. So on the left-hand side, I have my Julia editor and my Julia terminal. On the right-hand side, I have Excel, and I can take data from Excel, pass it to Julia, do complex calculations, and plot them back in Excel. So this is a particular example of a financial calculator. It's computing the yield curve by observing bond prices and looking for arbitrage opportunities. So you see the Excel is actually doing the coloring. So this thing has been colored green, which has the highest arbitrage opportunity that it found by evaluating the prices and computing interest rates, which is the code on the left side. Lots of organizations are using Julia. Government labs in the US, government labs in India are beginning to use it. I'm getting calls from a lot of them. In fact, I just gave a talk at the Indian Institute of Science in the computer science department last week. I'm doing one at TIFR next week, so Julia's picking on in the Indian academia, the Indian universities. It's already picked up in many of the foreign ones, and in the US ones especially. On Wall Street, Intel is a great partner of ours, and regulators are using it as well. So, whether it's the Federal Aviation Administration or the Reserve Bank of New York. So what are all these other users doing with Julia? So here are some real life use cases. In finance, the New York Fed, which is the equivalent of the RBI in the United States, models the US economy using Julia. This is a blog post that they've put out. I urge you to go check it out. The Federal Aviation Administration, working with Lincoln Labs and Johns Hopkins University, is using Julia to write the specifications for collision avoidance for aircraft. Every time you're in an aircraft, there is a box on it that avoids collisions. If two planes come within a minute of collision, this box will issue an advisory telling the pilot what evasive actions to take. So it will tell both the pilots to do something. Sometimes it may be counterintuitive, the advisory that it gives, but this has been the reason why air traffic, flying has been very safe over the last 30 years, is these airborne accidents have been avoided because of the system. The next iteration of this system is actually going to be completely specified in Julia, where all the algorithms are written in Julia and handed over to the various aircraft manufacturers. In retail, we've seen one of our customers do a modeling of healthcare demand, have a bunch of hospitals, I have a bunch of beds, I have different kinds of doctors and staff, and then I have models of epidemiology, of diseases, of different kinds of illnesses, and predict the future. Like, is my capacity enough? How does this affect my finances? What if there was a certain outbreak, or what if something happened? So that's a complex Monte Carlo simulation that one of our customers is doing. And then, specifically for the Internet of Things, we have a group at UC Berkeley that does self-driving cars in Julia, model cars, although I believe they're moving to real cars. So given the interest in the Internet of Things, I thought I would spend the last few of my slides talking about how people are using Julia for the IoT. So Julia's fast, it's easy to use, it's got all these amazing algorithms, you can do image recognition, image analysis, you can read your sensor data, you can run it on the ARM processor, you can do all this amazing stuff with it. So how do you put it all together and do some fun things with it? So this is a student by the name of Robin Dietz, who is still at MIT, and he took the Lego Mindstorm robots and controlled them with Julia. And here's what it does. So it's basically mapping this virtual environment, this physical environment, but creating a virtual map for itself using basically, Lego Mindstorm's kit, right? There's nothing in here that you cannot buy from a toy shop, actually. And it's actually, looking around and builds for itself based on the sensor readings, what its environment is, so that it doesn't go and hit into the walls. Great, but what if you wanted to do it on multiple robots? Turns out that the change in code to make it run on 2 robots from 1 was just 1 line of code, And the same code would now run on hundreds of robots should you want to, because Julia is parallel sort of, by design, and you don't have to do anything special to go from one to many. So this is, this project was playfully named as the Internet of Toys. It's also IoT. And another final video I have is on drift parking. It's not playing. So here's a project from the UC Berkeley where this car is actually programmed in Julia. The path planning for the car is programmed in Julia, and it's basically, figuring out how to park between those two spots in that parallel parking spot, but by drifting into it at high speed. Could you hit it once more? I love this video. This is using optimization algorithms using a package in Julia called Jump, which is running actually on the car on an embedded ARM processor. Perfect, thank you. And that's the real speed, and then this is the slow speed version. So Julia is, Julia is here. It's usable, it's ready, it's got amazing development tools, it's got a bunch of learning algorithms, it's got optimization capabilities, it can work with sensors, it can do what your mind can imagine, and you can scale up or scale down, and I leave it to you to come up with applications that are significantly more interesting than the ones I can imagine. Thank you. Good question. If we have time.
So we have a little time for questions, if any.
You mentioned support for scikit-learn, so is it also supporting text packages, NLTK, and?
I can't hear you very well.
The question was, is it also supporting text processing packages like NLTK? You didn't mention scikit-learn. Packages like NLTK, are they also supported through Julia?
So Julia has foreign function interfaces to call any C, C++, Python, Java libraries. And so what the community has done is that it writes what we call as Julian wrappers around the various ones. So scikit-learn is a popular one, and it's got these beautiful wrappers written for it. And I would think to wrap just about anything is at best a couple of days of work to get it working, and to make it high quality maybe a couple of weeks, few weeks. The challenge is always coming up with a Julian interface. What do I mean when I say Julian interface? Is a Julia programmer, once you start using Julia, you'll learn that, okay, I came here for performance, but the language has all these other amazing features like multiple dispatch. It goes way beyond object-oriented programming. It's functional in nature. So I don't want to mimic the APIs or the design of the package that I'm calling, because that was written in a different environment. So that's where sort of, the clash happens in the mind, is if you do a sort of a straight translation, yes, you can get it working immediately. But if you want to take your thinking to the next level for your users, for other people, then you have to put some more time into making it Julian, and usually that is always the hardest part. So for example, that car problem I just showed, the last one, that uses a package called Jump, Julia for mathematical programming, and what it does is it has Julian wrappers for all mathematical optimization, and that made it possible to create that application, which would have been a lot harder. So long answer to your question, but that's what it is.
That helps, thanks.
Yeah, hi. Quick question, I'm curious to know, you said it's much faster to use Julia for most of the regular algorithms that you're using. How easy is it to parallelize, say, an algorithm that we normally have to write code to make parallel? I mean, so does Julia take care of it on its own? Because some of the evolutionary algorithms are not easy to make in parallel. So can you do that via Julia, or do we have to still manually?
No, so Julia has parallelism baked into the language, but it's not automatic. So it cannot take a sequential code and automatically find the parallelism in it. But what it will do is it will give you a lot of facilities. So you could say this loop is parallel, or this body of code is parallel, or this function is parallel, or evaluate this comprehension in parallel. And by putting a few keywords in the right places, you can make Julia run in parallel effortlessly. There are also other frameworks. For example, we have a distributed arrays package. Now, if you use the distributed arrays interface, you do not have to write even these parallel macros, because your code will be automatically parallel under the hood. But then you have to write to that API, which are designed to be sort of like the sequential APIs, But of course, there is no free lunch, right? You can't just write, distributed memory code the way you would write sequential code. But at least you don't have to go. So think of it as writing at the high level code versus the assembly code. Today's parallel programming is almost at the assembly level. Julia lets you do it at sort of the Julia level.
Looking forward to it. Thank you.
After developing a model, should I still have to depend upon a developer to deploy the model, or I can deploy myself?
It's open source, you can deploy it. Or are you asking about like creating a binary or something?
Once you develop some linear model or any logistic model, could I deploy the model straight away on Spark, or should I have to still, because you said like it is an integration of model developer and the
Yes.
developer.
So you want to, so the thing is, Spark is not the answer for that question, because you can use Spark to scale up your data and your models if Spark has the algorithm built in.
The data is in a Spark, so
Julia can definitely take the data from Spark in a pipeline and then run the algorithm in Julia in parallel and then pass it on to the next stage. So it can interface with Spark, but I thought your question was, can I write my model itself in Julia and run it inside Spark? That's not how it works. Yeah.
And what about the security?
What security?
Data security. When you are talking about it will be parallel processing, that too in Julia. So what sort of security layer you do have?
Julia, I mean, it's a programming language, and what it will do is that you have to configure the environment around it to be secure. Julia makes some basic, things in it about security, but the focus is on performance. So, if I had to take an example, for example, Julia Box. So the way, we will shut off all the ports, right? All the other security things you have to do. But if you're talking about address space randomization, scrambling, encryption of binaries, those are features that are going to come in the, in the Julia professional release that the company is building. But those are not in the open source version at the moment.
Okay, thank you.
Hi, here.
Oh.
Hi, myself Deepak, and thanks for the knowledgeable session. Just my simple question is like how we can easily learn Julia. What are the sources available in Bangalore, or any kind of training session or any online session is available, and how about the online community is available so we can take help from them?
So Julia has a fantastic community. There's a mailing list which you can subscribe to and ask questions. Stack Overflow, as I pointed out, has a lot of the questions that you might have as a beginner already answered. I would start there. I would start as usual in Google, and then it will direct you to the same place when you ask the question. If you go to the julialang.org, which is the Julia website, and click on there's a learning link out there, which has all the tutorials, videos, everything sort of put out there. So there's a lot of learning material that's out there that you can use. And if you log into Julia Box, there's a tutorial inside that is pre-populated. So you can use that to get started as well.
Hi.
Hi.
So
Yeah.
do we have, let's say, the enough libraries or something in Julia for the data visualization purpose? So
Data visualization?
Yeah.
Yes, absolutely.
So graphs and
Yes.
let's say
There are many visualization libraries or packages in Julia. You can use, if you're a user of matplotlib in Python, those bindings are completely available in Julia, so you can call that. There is a native visualization library in Julia called Gadfly, which is written purely in Julia. That is modeled along R's ggplot, so it's a grammar of graphics interface. And then there are, but if you have more, if you want to use your graphics card for visualizing volumetric data or lot and lots of data animated, you can actually write directly to OpenGL layers as well. So depending on what you need to do, there are, although if you're starting out now with Julia, I would suggest using a package called plots.jl. And plots.jl can use many existing libraries as backends. So it can use JavaScript library like Plotly or D3. It tries to give you a uniform interface, but at the moment you try to generalize something, you have to give up something. So if you need very specific things, you have to pick one library. But if you want basic plotting, I would use plots.jl. It can even create terminal plots in the terminal itself using Unicode characters. Yeah.
Hi. I have a question on the maturity level of Julia in the data management world. What's the amount of data it can handle, and how is it in relation to or in comparison with R or SAS when it comes to data management and data manipulation?
It's a good question. So when it, in terms of programmability, Julia has the same kind of data, has tables or data frames as you